All right, this video is going to be part 1 of your final exam review. So first of all, what you see in front of you is the reference sheet you're going to get. So you'll get your full unit circle, you'll get your law of cosines, and you'll get your summation equations. There's a couple more that are actually built into the test. We'll address those when we get to those, but for the reference sheet, this is what you'll get. The test itself is 47 questions total. There are 33 multiple choice, and there are 14 open-ended, which is where your graphing is going to be, and then the systems of equations and stuff like that. Each of the questions are 2 points apiece, except for there are 2 3-variable systems, one using Gaussian elimination with back substitution or Gauss-Jordan, you get to choose, and the other using the Cramer's rule. So those will be worth double questions. You can choose to either use a scientific calculator the entire time, or you can use a graphing but only for the first 10 questions, and then you would have to put your calculator on the ground and not have it for the remaining time. So scientific is definitely your best option. This video is going to cover just one chapter. We're going to start with chapter 6. So this goes through each of the chapter reviews from your textbook, and I kind of just scaled back on what wouldn't be covered on your test. So in chapter 6, which is where we started in January, this is where this packet starts. We started with law of sines and the law of cosines. So the law of sines is one of the equations that you're not given. This hopefully is one of those easy ones to remember. This is your A over sine of A equals B over sine of B, or C over sine of C. And you can do any 2 of those at a time and then cross multiply, divide. So you're going to get questions in which you will get given 2 angles and the side, 2 angles and the side, right? Just like those. You do not have to worry about the ambiguous case. So the angle side, you don't have to worry about those because there won't be the second triangle. Then we got into area of a triangle, an oblique triangle. This is another formula that you need to know that's not given to you. So note that highlighted in pink is what you need to know, and in blue is what you will be given. We got to area, and then some word problems, either dealing with law of sines or cosines, and then we got into law of cosines. So the law of cosines are what will be given to you on that reference sheet. That would be something like 17, which we'll use for side, 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 or 23, side, angle, side. Again, some word problems there with law of cosines. Then we got into Heron's area formula. This is one that you need to know. A plus B plus C. Actually, that's a lie. Sorry. This is one that's given to you. It will be given to you in the instructions on the question. S is A plus B plus C over 2, and the area is the square root of S times S minus A times S minus B times S minus E. So these questions you will definitely have a calculator for, whether it's graphing or scientific, you'll have it for all of that. 6.3, we got into vectors, and we talked about component form. So this is your x2 minus x1, comma, y2 minus y1, where your initial is your 1s and your terminal is your 2s, and you leave it in component form. And then the magnitude is the absolute value, the square root of x2 minus x1 squared plus y2 minus y1 squared, or if you already have the component form, it's the square root of a squared plus b squared. Then you get into finding the sum of vectors. Okay, then we're adding, subtracting, scalar multiple on vectors in both component form and the IJ format. Then you're finding the vector in the same direction. So this you put the component form over the magnitude. That is, again, highlighted in pink, which means you need to know that one. The dot product comes up. So if it asks you to find the dot product of 2 vectors, we multiply the first term in each, and then add it to the second term. So if this is u1, comma, u2, and then v1, comma, v2, then we find the dot product by multiplying these two, u1 times v1, and then add it to the multiplication of these two, u2 plus v2. And it will be an individual number. Dot product is just one number. Okay, that's more dot product. Okay, angle between two vectors. This will be given to you. This is one that requires the calculator. So it's the dot product of the two vectors over the product of the magnitudes. And then we second cosine that whole thing to get the angle in between. That would be both 69 and 70. Okay, under 47, I want you to add if the magnitude, same set of directions, but if the magnitude, let's say, is 5 at the end. So the way that it is for 47, you're finding your unit vector. And unit vector means that it's a vector in the same direction, but it has a magnitude of 1. If it said it has a magnitude of 5, then you're going to do what you do for 47, but then you're going to multiply it by 5 at the end. And that is what will be covered from chapter 6. So the next video will go over chapter 7. So law of 7. Chapter 7 is your systems of equations. So you're going to get questions that are straight up systems of equations. You could get word problems, or if you remember these things like our supply and demand questions, you could see stuff like that. You will get systems of equations with 3 variables in 2 ways. One is 7 had your partial fraction decomposition. So you remember these where you have to break your equations apart and put them over the factors of your denominator. And then find out what the bottom's missing, multiply it in the top, find out what the bottom's missing, multiply it in the top, and add them together. So all of that was in 7.4. That comes from that chapter here. One is the Gaussian elimination with back substitution. So this is where you're looking for your diagonal of 1s with the zeros below. And then you would do back substitution to work backwards to get your answer. So that's one of the ones that will be full out, and that's worth a double question, which is 4 points. The other is to use Kramer's rule, which is on. Under operations with matrices came your addition, your subtraction, your multiplication, and your determinants, and your inverse. So all of this came from chapter 7. Remember, inverse was 1 over the determinant, and then we switch the A and the D, and we negate the B and the C, and then you multiply it in. Our determinant is our like little Jesus fish. How do we do the determinant of a 3 by 3? This is where you add the other columns, right? So like -2, -6, 5, 4, 0, 3. And then you got to go down this way. And then you got to go back that way. So this is part of the Kramer's rule process, but you could also get a question that's just the 3 by 3 part of it. And then you use that to do the area. You use that to test for collinear. And then it comes back again for Kramer's rule. This question is your other one that's worth double the points. So Kramer's rule, you remember you find D, doing the X's, the Y's, and the Z's, you find D of X. Doing the constants, the Y's, and the Z's, you find D of Y. X's, constants, Z's, and you find D of Z, doing the X's, the Y's, and the constants. And then to get your X value, you put D of X over D. To get your Y value, you put D of Y over D. And to get your Z value, you put D of Z over D. This is one of those questions that you'll have to show your work in order to get the credit for that question. Like a systems of equation, I don't care the other ones. I don't care how you do it, if you choose to use elimination or substitution, whatever it is. But those specific questions with those specific set of instructions, you will only receive credit for that question unless or if you have the work to back it. Okay. Okay, questions on chapter 7. So a lot of matrices, systems of equation, that was chapter 7. All right, chapter 8 started with your sequence and series. So this had arithmetic and geometric series and sequences. This is where factorials came into play, right? What does it mean if it says 18 factorial? You keep multiplying down, so 18 times 17. If it's something like this, then the goal is to take the bigger one, break it down until you get the smaller one, and simplify from here. When you get to this, like look at the sigma notation here. Actually, not that one. The ones that are adding and subtracting, that came later. You can also use your summation because I'm going to give you those formulas. So the ones that we did in chapter 11, you can apply to a lot of those different places. When you get to 8.2 is arithmetic. What is an arithmetic sequence? What does that mean?
You're constantly adding.
You're adding or subtracting the same thing. All right, arithmetic is adding or subtracting the same value, and the formula for arithmetic is A1 plus D times N minus 1. When you get into this section, they also did partial sum. So the sum of an arithmetic was N over 2 times first plus last. These are all things that are not on a reference sheet. These are all things that you would need to know. But, like, look at number 39. This is an arithmetic sequence, so you can use N over 2 times first plus last on this, but you can also now use your other summation rules. So if you do what we just did in 11.5, what would you do with that? Split it up. So I'd make it 2J minus 3, and then what? Bring the 2 to the front, so it'd be 2 summation J minus the summation of of 3, sorry. And then you'll have that formula, which is the N times N plus 1 over 2, and you can do it that way. So if there's a sum or a difference or something's being raised to a power, you can split them now using those power rules. You can go back to the old way, which is the N over 2 times first plus last, but you can also use that way. All right, then came geometric. What is a geometric sequence? You're multiplying by the same thing every time. And the formulas that we went over in the geometric section are AN is A1 times R to the N minus 1. That's how you would find any term in that sequence. And then the sum of a finite was A1 times 1 minus R to the N over 1 minus R. And the sum of an infinite is A1 over 1 minus R. Again, none of those are given to you on a reference sheet. Those are all things that you would need to know. Okay, then we went to 8.4, and 8.4 was your binomial coefficients. Okay, your CNR, which is n factorial over n minus r factorial times r factorial. No, sorry, C doesn't have that one. It's this. And you did your binomial expansion. So this is where you want to know Pascal's triangle. And then 8.5 started your probability. So you needed to know PNR. You needed to know permutations would be like a factorial. You need to know the difference between a permutation and a combination. Remember, permutation, the order matters. Combination, it does not. And you need to know the difference between your and your or statements. So if it said you are pulling a card out of a deck of cards, what's the probability you are getting a red or a jack, let's say? Then if it's an or statement, you have to ask yourself, is it mutually exclusive or not? Mutually exclusive means it can't be both things. So if I said a red card or a jack, could that be both things? Are there red jacks? Yes. So that would be not mutually exclusive. If I said a heart and a club, can it be both things? No, a heart and a club, those couldn't be the same thing. That would be mutually exclusive. Mutually exclusive, you do the probability of the first thing plus the probability of the second thing. If it's not mutually exclusive, then it's the probability of the first thing plus the probability of the second thing minus the probability of the overlap. Then you've got an and statement, and an and statement would say something like you're pulling 2 cards out of a deck. What's the probability of getting a heart and a club? And for these, we need to know if they are independent or dependent? Independent means one does not affect the other. So if I pull a card out of the deck and I replace it, that's independent. If I pull a card out of the deck and keep it, that's dependent. If it's independent, then we do the probability of the first thing times the probability of the second thing. One does not affect the other. But you do assume that the first thing has happened. So the probability of a dependent thing would be the probability of the first thing times the probability of the second thing, given the first has already happened. God bless you. So if I wanted a red card and a club, the probability of pulling the red card, if I keep it, now affects the fact that I want the club next. All right, and that's chapter 8. All the probability stuff. Questions on any of that? Okay. Okay, chapter 9 is your conics. So this is the chapter in which you have to know circles, ellipses, hyperbolas, and parabolas. So we'll do a quick recap on the equations you need to know. Circles, you need to know the standard form. X minus h squared plus y minus k squared equals r squared. Where your center is your HK and R is your radius. So in these kinds of questions, you can get given information about the circle and asked to get the equation, or here's the equation, find the information and graph it. You are graphing a circle, a parabola, an ellipse. Those are going to be on the open-ended portion. Then came the parabolas. Well, the parabolas in standard form because we did parabolas in general form at the beginning of the year. And these you had two kinds. It was either, if it was up or down, then it was an x squared. So it was x minus h squared equals 4p times y minus k. And that parabola either opened up if it was a positive 4p or down if it was a negative 4p. And then the y minus k squared equals 4p x minus h. It opens to the right for a positive 4p, to the left for a negative 4p. And for these, you might be given the equation. Again, ask information about it, or it could give you information and ask you for the equation. Remember when you're graphing these, that your vertex for either of these is your HK. P is the distance from the center to the foci, or the center to the directrix. And the this is focus. Sorry, there's only one of them. The focus is a coordinate point, and your directrix is a line. So it's either an x equals a number or a y equals a number. So if it opens up, you've got your vertex, your focus inside, your directrix outside. It does not cross through the directrix. And if it opens to the right or to the left, you've got your curve, your vertex, your focus inside, your directrix would now be a vertical line. Questions on parabolas? Okay, then came ellipses. These are your ovals. These had x minus h squared over a squared plus y minus k squared over b squared equals 1. Or, and the order doesn't matter, what mattered was the bigger denominator. So x could still come first, but the y gets the a. A is bigger this time. Order does not matter. Yeah, sure. For both of these, your HK is your center. A equals distance from center to vertices. B is the distance from the center to the co-vertices. And C is the distance from center to foci. And for ellipse, c squared equals a squared minus b squared. Remember, it's the opposite of the equation's middle term, or middle sign. So ellipses are a plus between them here, but a minus with the a and the b. If the a is under the x, it's wider than it is tall, because you would go from the center to the right and left your a, and then you'd go up and down your b. If you have the larger denominator under the y, then you're starting at your center, you're going up and down your a, and you're going right and left your b. So it's taller than it is wide. You won't have to graph your foci, like it's going to give you an equation. You're going to have, this is another one that obviously you're graphing. You don't have to graph your foci on it. Questions on ellipses? Okay, and then the last one was your hyperbolas. So this time the A is first. The order is important here. If it's horizontal, then the X comes first. If it's vertical, then the Y comes first. A is first. All the relationships between A, the center, and like what A, B, and C are all the same. So all of this is the same. HK is your center. A is the distance from the center to the vertices. B is the distance from the center to the co-vertices. And C is the distance from the center to the foci. This time c squared equals a squared plus b squared. So the sign flips in between. And we have asymptotes. So y equals k plus and minus if it's vertical. So the x has, no, if it's horizontal, so the x has the a, then it's b over a, x minus h. And if it's y equals k plus and minus a over b, x minus h, if it is the y that has the a. If the x has the a, then I would find my center. I go right and left the a. I go up and down the b. I draw my little box. I draw the asymptotes. And my branches go right and left. If the A is under the Y, then I find my center. I go up and down the A, right and left the B. I draw the little box. I draw my asymptotes. And my branches go up and down. Questions on those? So again, you're going to have to graph one of each of those. You're graphing a circle, finding information about the circle. You're graphing the parabola, finding information about the parabola. You're graphing the ellipse, finding information about the ellipse, and you're graphing the hyperbola, and you're finding information about the hyperbola. Those are all open-ended questions. So that's 9-1 to 9-3. Okay, and we got into parametric. So remember your parametric. You had 3 different types of questions. One like this, where you got given 2 equations and it asked you to graph it. So you would plug in a t into both, you would get your x and y, and then you would graph it. The biggest thing is don't forget your arrows here. And they go, so like if I were to graph this, a lot of our examples went like this, then my arrows go towards the bigger t. So if this was the last t, if that point was the result of the biggest t, then my arrows would point towards it. Away from the smallest t and towards the biggest t. Then the second type was eliminating the parameter. So for these, we solve one equation for t and then plug into the second equation. And your answer is one equation with no t. You eliminate the parameter and the parameter is t. And then the third type was making a set of parametric equations. So this is the one where let's just say this was your A and this was your equation. One of the equations is going to have a t in it and one isn't. So you're going to solve the one that has the t for the other variable. And then plug the expression in. Second equation. So in this case, if x equals t, then in place of this x, I'm putting t. And then your answer for these are 2 equations. Both have t. It's an x equals and a y equals. Okay, then you got into polar. So polar coordinates was 9-5, where you had to be able to plot a polar coordinate, okay, which is, you're going to do that. You're going to have to plot a polar coordinate, convert from polar to rectangular or rectangular to polar. So if I'm going from, let's just say I wanted to graph this one, 5 and negative 7 pi over 6. Then you're going to have a polar grid. But negative 7 pi over 6 would be this angle here, because 7 pi over 6 would be here, and I would fold it like a hamburger. And then 5, I would have 1, 2, 3, 4, 5 circles, and I would go out to the 5th circle, and that would be my polar coordinate. To get additional points, actually, all right, so this I took off. But you do have to plot it and you do have to convert it. So if I'm going from polar to rectangular, this is where we do r cosine theta and r sine theta. So I take the r that's there, I multiply it times the cosine of whatever that angle is, and then I take that r and I multiply it times the sine of whatever that angle is. And then back the other way, rectangular to polar, our r is equal to the square root of x squared plus y squared. And our theta is tan negative 1 of y over x. And remember, there's 2 answers to that, so you choose the theta based on the original location of the point. So for example, 107 here, 0, -9 is where? Where would 0, -9 be? If I plotted that rectangular coordinate point, where would that be? This is a good sign. Where would 0, -9 be? Be down here, yeah? So if I had to choose between two angles on theta, because if it was -9 over 0, it's undefined, right? And tangent is undefined at pi over 2 and 3 pi over 2, I would choose which one? 3 pi over 2, because that's where the original coordinate point is. So there will always be two correct answers to the tan -1 part, but you will choose based on the location of that coordinate point. Yeah, it's on your reference sheet. Yep, it has the full unit circle. I would say you want to add on your tangents. That would make life easier. Yeah, but the unit circle's on there. All right, as far as sketching the graphs go, I'll tell you right now that you're going to do the circles could be fair game, like 127 and 131, and then rows. So something like 137. You can ignore the limicons and you can ignore the lemniscates. So circles and roses. Know how to graph those. So something like r equals, if it's r equals 3, then it's just a regular circle with a center at 0, 0, and you'd go out to the third ring in each side, and I'd draw a circle. If it's at r equals 3 cosine theta, do you remember how you tell if it's above, below, right, or left? Cosine is symmetric to the polar axis. A positive A puts it on the right. So I would go out to 3 and I would draw it. If it's at -3 cosine theta, I'd go to the left and I'd draw it there. If it was sine, it'd be above or below. A positive sign is above. And a negative is below. So this would be up and this would be down, because sine is symmetric to the pi over 2 line. Or, well, no, 127 and 131. So this is like 127, this is like 131. And then 137 would be your roses. So the rows, remember you do A equals the length of the petal, N, which is the number next to theta. If it's odd, that is the number of petals. And if N is even, we double it. So I'll change it so that you can draw that one. But let's say it said 4 cosine 2 theta. This is an even amount. This would have 4 petals. The length of each petal would be 4. It would be symmetric to the polar axis because of the cosine, and if it's even, it's symmetric to all 3. Then I would set this equal to my petal length. The cosine of 2 theta is going to equal 1. Cosine of theta is 1 at 0. 2 theta would equal 0, and theta would equal 0. So I'd go to the right, 1, 2, 3, 4, and I'd make a petal. And then because it's symmetric to the pi over 2 line, I'd go to the left and I'd make a petal. And then that it's symmetric to the origin or to the pole. So my other petals go top and bottom. So these questions are open-ended, obviously, because they're the graphing ones. If you even just gave me like 1 or 2 petals, I'll give you one of the 2 points, right? They're only worth 2 points. But 2 points, 2 points, 2 points adds up. Questions on those. So again, don't worry about reviewing the limicons or the lemniscates. Just the rows and the circles. All right, chapter 10. Hopefully we're getting more recent, so hopefully remember this stuff. This isn't too long ago. Chapter 10 was your three-dimensional coordinate points. So you don't have to plot these, but you have to find the distance between them. Remember, it's just like the regular distance formula, but we add on the variable y2 minus, y1, and z2 minus z1. And the midpoint, just like the regular midpoint, except we add on a variable. And then the sphere is like the circle with an extra variable. So it's x minus h squared plus y minus k squared plus z minus j squared equals r squared. And then something like this where you might have to complete your square to find the standard form and find the center and the radius. Questions on those? That was 10-1. All right, and then where we just left off, which is chapter 11. So in chapter 11, it might ask you to find the limit by direct substitution, where you're just plugging your value in. Okay, for something like the ones under 11.2, you won't have a graphing utility for these questions. Remember I said you can, if you have a scientific, you can use the scientific the whole time. If you have a graphing only, then you can use it for the first 10 questions, but then that's it. So for these, we want to factor first. Factor first, and then cancel, and then plug in. So if you plug in from the beginning, you get 0 in the denominator and it's undefined, which means there's a hole. So you've got to be able to factor it, cancel them out, and then plug in. Then comes the derivative, and you don't need to do the long way. I would do the exponent. So if it said negative 2x to the third plus 4x squared minus 5, I take the exponent, I bump it forward. 3 times negative 2 would be negative 6x, subtract 1, so it'd be 2. Bump the 2 forward, 2 times 4 is 8, subtract the 1, it'd be x to the first. This would be an x to the 0, so when it bumps forward, that entire term goes away. And my answer would just be negative 6x squared plus 8x. So constants always go away. Be prepared for, like if you look at 70, the exponent would be a half. You'd bump the half forward, subtract the 1, and have to move it back to the bottom. I didn't do the slope at a point, so like it's just the derivative, the slope at a point, and then this one is your end behavior. So this is based on horizontal asymptotes. N is the exponent in the numerator, m highest exponent. N is highest exponent in the numerator, m is highest exponent in the denominator. If n is greater than m, the limit does not exist because there's no horizontal asymptote. If n is equal to m, then it's the leading coefficients of your numerator over the leading coefficient of your denominator. And if n is less than m, then the limit is 0, because that's where your horizontal asymptote would be. Questions on that one? Okay, and then the summations. I'm going to give you, this is on that reference sheet. You'll get given that. Remember, you want to break them apart. So anything that's got a sum or difference, we're going to break them apart. If it's got a coefficient, it gets bumped to the front. So there's a couple of these. I feel like these are the most recent things. Hopefully these are fresh in your mind. So there's a couple from this section. I would say point value wise, because your three systems